Hello everyone, welcome back. So here I have the geometry and I have the final points, the RBD points, and what I want to do now is before we start clustering this, I want to separate the pieces that have moved versus the pieces that did not. We did this previously, but I want to do it again to make sure that everything is clear. And the idea is, after we separate these two groups, we want to only work on the pieces that have moved throughout the lifetime of the sim, and on those we want to cluster them and separate them into groups by space, but by their original position. And in this case, I'm gonna split the geometry into 4 clusters and then work on each cluster separately, and then run the same thing on the other clusters. The idea is not to have too many clusters, but not very few as well, not just 2 or 3. We want to have 4, 6 or 8 or something like that, but we don't want to divide the space into very small domains, because that's gonna create visual issues later on. And let's set up the first part to separate the points that moved versus not. So what I'm going to do is I'm gonna create a time shift and move this to the last frame, 240. And I'm gonna create a rest attribute on the first frame, and I'm gonna time shift this to 1 and connect it on the second input, so my rest position is always based on the first input on this one, which is a frame 1. And I'm gonna go to the last frame and let's create a point VOP, and in this point VOP I'm gonna bind import the rest attribute and then subtract that from the original position. And I'm going to connect that into the color, and now it's giving us back a vector. We don't want the vector, we want to compute the length of that. As you can see now, everything that moved is has a white color. The pieces that didn't move or moved just slightly, they have a darker color. And I'm going to use a fit range here, and I'm going to also ignore anything that just moved a tiny bit. So I'm going to set this to 1 and this to 2, and this way we have all the pieces that have moved. Anything that is black it didn't move at all. And let's create a wrangle node and create an attribute called move, and it's equal to 0 by default. And if the color, if at cd.x is higher than, let's say, 0.2, we want to change that move attribute to be equal to 1. Okay, so let's delete based on this now. So blast, it's a point, and at move equal 1, and now we deleted everything that didn't move. So this is the static part, and this is the piece that moved, and we want to copy this attribute onto the points. Okay, so let's do a transform pieces, and this is our transform pieces, and this is the geo. And because we use the time shift here, we are locked at the last frame, so we want to have the points continuously change and animated so we feed them correctly, but we also want this move attribute. So what I'm going to do is I'm going to attribute copy from here, and we can do the rest, that's fine. And I'm going to copy the move attribute, and by default it's going to use the point number, so that should work just fine. So we have a move attribute, and now when we plug this in, let's take a look. it will copy certain attributes from the points, but it's not going to include that. And what we need to do is we need to tick on copy template points, copy template attributes. I'm going to include the move attribute. So now if we middle click, see it's propagating that from the points, from the RBD points onto the geometry. And if we do a blast, say at move equal 1, and make sure it's a point attribute, you can see we separated the two. So I'm going to say this part moved, and this delete not selected. Sorry, this one static, and these guys moved. And we want to work on this only. We don't want to do anything for the static. And if we scrub through the timeline now, we're going to see all these points, all these pieces moving. And that's what we want. And we guaranteed that only the things that moved and could become a debris emitter are going to be included. Now, the last thing we want to do is we want to cluster them and create 4 different groups for these points. And the best way to do this is to use packed primitives. We could do it at this level as well. So maybe let's do that here instead. And I'm going to use, depending on the sim and how the pieces are moving, sometimes it's better to do this clustering at a different frame, let's say like this. But it really depends on the type of sim. In this example I'm going to use, because it's everything is shooting this way, I'm going to use the first frame, and it should give us a nice result for separating the emitters. Okay, so now what I want to do is I want to cluster these points and use their current position, the world space position, to group them together. And the best way to do this is to convert each of these pieces into a point, and then run the clustering on those points, and then copy the attributes back. And the best way to do this is to pack the geometry. And I don't need a new name attribute. I'm gonna untick these two. I'm gonna tick on create packed geometry. I'm gonna change the visualizer to points. And let's see. So we should have a name attribute here. And it's not transferring the name attribute. It's on the point level. So all I'm gonna do is promote the name attribute from point to primitive. I'm gonna keep the original copy. So now we should have a point per piece. Cool. I'm going to use this to do the clustering. So let's put down a time shift, make sure we're always on the first frame, because this is the one I want to use. And I don't need the packed geometry. I only need the points. And to make this lighter, I'm going to use an add node and tick on delete geometry but keep points. So I only have points now. I'm going to use a cluster points node. And the way it works by default is it's going to use the point position and try to group them into a set of points that make sense to be together based on their position. And what I want to do instead is provide my own set of points. And I have a box that I'm going to copy so it matches my previous example. And this is just a box node, and it's surrounding the points. And then I'm going to transform it down and use an add node to delete the geometry and keep only the points. And then I'm going to connect that, and now it's grouping the geometry based on this information. I'm going to move it back a bit, something like that. I basically want this to be grouped together and this to be grouped together this way, because it was here and I don't want this to be a separate group. I'm gonna treat everything at this level to be a one unit, and then this is a cluster, and then this is cluster. Maybe you can move this up a bit. Yeah, something like that. And these are my 4 clusters that I'm gonna use. So let's create a blast node. Let's say at cluster equals 0, and delete non-selected, and that's cluster number 0, number 1, number 2, number 3. Let's see. So you have 0, 1, 4, and 5. And let's set this to 8. See how that affects. So we have 0, 1, 4, and 5. Let's set this to 4. Set this to 8. I'm gonna lower the refinement. And I want to basically get 4 increments, but it's giving me 0, 1, and 4 and 5, which is fine because we're going to have separate nodes. So we'll say cluster number 0. It doesn't have to be a continuous increment, and we can always rename them 4 and 5. And this is just the cluster name. That has nothing to do with the it has nothing to do with the order, and we're going to use a switch node like this, and this way we're going to have 0, 1, and 3. So those are my 4 clusters. Now, one thing I didn't mention is that this node it adds a cluster attribute, and that's what that's where the colors are coming from, and it uses these points in space to try and group the incoming geometry based on that. And that's pretty much it. We're gonna now loop over each one of these clusters and create the emitters and run a separate pyro sim for that to create the smoke and debris. Thank you guys for watching, and see you in a bit.